All right, so they're talking about single and double replacement reactions. Most people find these easier. A single replacement, also known as a displacement reaction, is a reaction in which one or more element replaces another element in a compound. So A plus Bx yields Ax plus B. Notice in this, both A and B are metals. X is a non-metal because metals bond with non-metals. Okay? Metals bond with non-metals. Other example would be AY plus X yields AX plus Y. The X has kicked out the Y. So my best example of this is my favorite example of this. I need 3 volunteers. Okay, Amanda, come here. Why don't oh, you gotta come here, Tommy. Oh, you gotta come here, Tommy. Tommy boy. Come on, Tommy boy. Let's go. Come on, Tommy boy. And come on, Zay. Both Tommy. Not like that, boys. 2 lock elbows. So in this, well, Tommy and Zay, both Tommy and Zay are metal. Okay, both Tommy and Zay are metal. Zay and Amani decide that they're booed up. A metal bonded with a non-metal. Okay, a metal bonded with a non-metal. Oh, Zay's over here. He's lonely. He's by himself. Sorry. Tommy, so sorry, Tommy. You're all lonely. So what Tommy is going to decide to do, he said he can take on Zay. What? Get out of there, Zay. No, metals don't bond with each other. And now, because Tommy was tougher than Zay, that's the activity series talking about. We won't apply that today, okay? But because Tommy was tougher than Zay, poor old Zay's over here by himself all lonely, okay? That's one way a single replacement reaction can occur. Yeah, you're fired. I'll be back with you in a minute. Come here, Chicago. Look out the window. Sorry. You and Tommy are together. You over here, mine. Oh, you take your booth? What? Okay, so you 2 are together. Now, notice in this case, Amani, she's female, non-metal, okay? So Amani's decided, wait a minute. Zay's her boo. Not Zay her boo. Tommy's her boo. And so she's going to go kick out Shakira. Now, you 2 are back together, like you're meant to be. And now poor old Shakira is just lonely by herself, okay? That's a single replacement reaction. A single element is replacing something else. In this will always be an element plus a compound makes an element plus a compound. Okay? Okay, I need to borrow you people back there if you want. Okay. I'll try to use different people next time. An element plus a compound is an element plus a compound. An element plus a compound. People person by themselves an element. So an activity series, I will not apply the activity series today. We're going to do an activity over this probably next week. Okay, so we'll start applying this. I will tell you today, if you write no reaction, I'm going to know you looked the answers up on the internet. Okay, they don't all happen. I mean, I like to think of it like this way. I mean, like if I do like me and my wife, somebody wanted my wife, well, nobody can kick me out because I'm the greatest. I have the highest activity series. I have the most energy, so I'm the greatest. So nobody can kick me out. So, like, Whitey's ugly, so anybody can kick him out. He's in the bottom of the activity series, okay? So, that's the thing there. But elements replace less active elements. The reverse does not occur. This is why you see and if you look at the activity series in your book, gold is not very reactive, okay? So gold doesn't react with very many things. So if you put gold in something, it does not react. Tomorrow I will get a penny, and I will do a penny. I'll react to penny and silver nitrate, and you can see because silver has less energy than copper, it will react some. Okay, no reaction curves, we won't do that. Okay, example of single replacement reaction, metal replace non-metals. Now notice, Mg, the metal, is I just going to kick out Fe, okay? We'll kick out Fe, so Fe is by itself, Fe is by itself. Now, why is it FeOH3 here and MgOH2 here? Go ahead. Mg has 2 plus charge, we're talking about iron 3 here, very good, okay? This also happens here, okay? Most people kind of get confused by this one. Water is really HOH, okay? Water is really HOH. So when I look at this, Na plus HOH, well, Na is a metal, H is a metal, so Na is going to pick out the H, okay? Na is going to pick out the H, so it would be NaOH be together plus H, but why is it H2? Why is it H2? What? What? No. Why is it H2, not just H? I heard the answer. Yeah, because it's diatomic. It's diatomic. Right? That's how it's found in nature. All right, active metals can replace hydrogen and acids. We're going to do this activity at the end of the year. Not the end of the year, but towards the end of the year. Talking about gases, we're going to use magnesium plus hydrochloric acid, and it makes hydrogen gas. Okay. Metals are the most common way of doing this. A metal kicks out a metal, but a non-metal can kick out a non-metal. Okay. So in this case, why does Cl kick out I and not K? Because like replaces like. A non-metal can only replace a non-metal. A metal can only replace a metal, okay? A metal can only replace a metal. Because chlorine's a non-metal, which one of these things is the non-metal? Iodine. Once again, these are 2s here because they are diatomic. No reaction, we won't do that one today. All right, double replacement reactions, also called a metathesis reaction. They switch partners. So I need to see Whitey Anaya. Come on, Whitey Anaya. Come on, Brooklyn and Aiden. Remember, metals come first. You're up there. Remember, in a chemical equation, metals come first. Metals come first. So in this, I just decided I was going to make metals. So all right, y'all need to lock together. This is the easiest way I like to think this is the FOIL method in math, okay? So, Whitey's decided he don't want Brooklyn. We don't know who Whitey is. So he's going to come over here, and they're going to switch. But you always come in the front, okay? The first, get back to the original position. Get back to the original position. Get back to the original position. So, why I say the FOIL method? The first person, oh, I messed up here. I'm sorry. The first person goes with the last person, okay? First, outer, inner, last. And then the middle people go together. But remember, the metal always comes first in a chemical equation. Okay, and the metal always comes first, so switch. That's our double replacement reaction. Oh, you guys got to switch. Because I wanted the first to be last. All right, does that make sense to you with a single double replacement? Most people find these easier. Most people find these easier. Thank you, ladies and gentlemen. There are 3 types. We won't really get into classifying the types today. This is a next week issue. Precipitation. And precipitation is when you mix 2 liquids together and get a solid. Okay, when you mix 2 liquids together and get a solid. A gas forming is when you form a gas. And then neutralization is an acid plus a base, also known as the acid-base reaction. So precipitation, so I can mix these 2 liquids together and it makes a solid. Like I said, we'll talk about this a little bit more later. All right, so let's work some examples out. Let's say that Mg Mg plus H. Plus HCl. Yes, ma'am. What? I didn't present that? Thank you for seconding that. Sorry about that. Now can you see it? Sure. Mg plus HCl. So I need to classify the reaction first. That's always the first thing I want to do. So what type of reaction is this? A single replacement, because it's an element plus a compound, okay? An element plus a compound, so it's a single replacement reaction. So what's going to kick out what in this equation? I am? You sure? I don't know then, dog. What? Anything happened there? We have to watch the Zoom. Hope it showed up on my Zoom. Okay. So if you need to move so you can see better, by all means do it. So what's going to kick out what? What? The hydrogen kick out the chlorine. They're bonded together. They can't kick each other out. Magnesium's a metal. It's a cation, isn't it? You're going to kick out the cation in this, okay? So hydrogen would be by itself. So plus H2, because hydrogen's a diatomic element, plus, what's my other compound going to be? Magnesium chloride, and it would be MgCl2, because magnesium has a 2 plus, chlorine has a 2 minus charge. NH4Br plus NaOH yields what? What type of reaction? Double. Yes.
If you're riding on smart, you can't see.
Now, this could also possibly be a synthesis, couldn't it? What? I know you can't see, Gary. I'm just trying to just watch the Zoom. I don't know what's happening on my computer. It's been stupid today. Okay. So NH4Br plus NaOH. This could also be a synthesis reaction. But you know, a synthesis reaction only going to have one product. Do you know of anything that has NH4, Br, Na, and OH in it? Any compound? So that's kind of process what you got to think about it. So it cannot be a synthesis, okay? Because a compound plus a compound, it could either be a synthesis or a double replacement. But because there's nothing with all these elements in it, process elimination, you can cut synthesis out. So what's the first thing? So what's going to go with what? NH4 is going to go with what? What? So you can, if it helps you to put, did that show up now, guys? If it helps you, you can put parentheses around this stuff, okay? You can put parentheses around this stuff. So the NH4 is the first thing, and it's going to go with what? The OH. So NH4 OH plus what? Na has what charge? Br has what charge? -1. It would be NaBr, not BrNa, because the cation comes first. Darren, you never told me. Did that help? Can you see now?
Yeah, I can see it.
Okay, I don't know what the deal was. All right, let's do another one. Let's go with But it's not as an element right there. It's in a compound, isn't it? So no. All right, so Fe plus NH4NO3. What? Well, hydrogen is not a metal in there. We have to, you can use it as a metal or a cation, okay? I can't just take hydrogen out of the middle of it, okay? So we know that NH4 is a cation, don't we? So that's what Fe is going to kick out. Actually, I don't want to do this. I don't want to do this. All right. I'm sorry I did that. I don't want to do that one. I'm sorry. Let's do Fe plus RbNO3. Fe plus RbNO3. What type of reaction is it? There's two options, isn't there? A synthesis reaction or a single. You know anything that has Fe, Rb, and NO in it? So it can't be a synthesis. So it's a process elimination. It's a single replacement reaction. So now, what's going to kick out what? Fe is a metal or non-metal? Metal. So it's going to kick out what? Rubidium. So rubidium is going to be by itself. So is it Rb2? No, because it is not a diatomic element. Plus, what's my other thing going to be? What iron is it? Because we know iron is a transition metal, don't we? What is the oxidation state of iron? What's the charge of iron? It doesn't matter. As long as it doesn't explicitly tell you. So as long as you pick one that is an oxidation state of iron. So in this, you look at your periodic table, you turn to the back side of your periodic table, and you see what are possible oxidation states for iron. And you see that, I think it's the back side of the periodic table. No, sorry, so it's on the front side of the periodic table. You look at iron and you see that it has possible oxidation states of 2, 3, and 6. So it could be FeNO3 2, FeNO3 3, FeNO3 6. All those are correct answers. As long as it is one that exists. I couldn't have FeNO3 because iron 1 does not exist. It could be FeNO3 2 plus Rb. Is that what you're asking? Yes, sir. All right, next one. Let's do, what you do, CaO plus CO2. CaO plus CO2. Everyone agrees that it is what type of reaction? Double? Everybody agree with that? It's wrong.
I don't agree with you.
It 100% correct is a synthesis reaction. Because it's two compounds together, isn't it? It's two compounds. But do we have something where I can add this together? I know something that has CaO and C in it, don't I? So it's a synthesis reaction. And what would it make? Calcium carbonate. So CaCO3. That's what I've been trying to go over and saying is there's something that has all these things. I2 plus KF. I2 plus KF. So, it's a what type of reaction? No, because I don't know anything. It's not a synthesis because I don't know anything that has K, F, and I in it. Do I think? So it's a single replacement reaction. And SR is perfectly fine with single replacement. So what's going to kick out what? I is going to kick out F. So F by itself, but we know it's F2 because it's diatomic, plus Ki. Well, very good question, Waddy. Because this 2 just thinks it's diatomic. So I want to think of it, this is potassium iodide. K has a plus charge, I has a minus charge. No, you don't balance it. That's fine. No balancing of it. Let's do another one. Well, go ahead. Because like replaces like, so they're both non-metals. So I can only kick out a non-metal. And in this, my two options are K and F. K being the metal, F being the non-metal. So let's say we did CS plus KF. CS plus KF. Now is CS a metal or non-metal? So it's gonna kick out the K now. So K will be by itself plus CS F. H2SO4 plus KNO3. I hear a synthesis. Does everyone agree with that? No. I don't know anything that has HSOKNN, do I? So what type of reaction is it? Double replacement. So what things are going to bond together? K and SO4. I agree with those are going to bond together. That's the first thing. And, those are the middle things, aren't they? And what's the other thing that's going to bond together? So we'll figure. Now, let me finish this one. K and SO4, what's the formula of potassium sulfate? Because that's what K and SO4 make, is potassium sulfate. What's the formula of that? K2SO4. You see why naming is so important now, guys? It's K2SO4. Because the metal always comes first. Potassium is K plus. SO4 is 2 minus. So it makes K2SO4. Plus, what's my other thing going to be? Well, I'm done with my S. I put parentheses around this. I put parentheses around this. I'm done with my K. I'm done with my SO4. So what's left? No, I'm done with my K. I've used my K already. Not H2. HNO3. Because H has a plus charge, NO3 has a minus charge. That just comes with balancing, okay? If there's a 2, Aaron asked a very good question. Why is it H2SO4? Because that's how these charges cross. H plus, SO4, 2 minus. Mm-hmm. Last example, and I'm going to go get your homework for you. I just had one in my head. BaO plus FeOH Give you a second to try to figure it out. I'll give you a second to try to figure it out. So what's the first thing? BA is going to bond with what? OH. And then the Fe and the O are going to bond with each other. So what's going to be the formula of barium hydroxide? Oh, Ba, parentheses OH2. Heard that. Plus, what's the other one? Fe2O3. Because Fe has a 3 plus charge, doesn't it? I got that from here. O, we know has a 2 minus charge. So it'd be Fe3. That'd be Fe2, Fe2O3. Why? Because when you, let me find my mouse. Because when you cross them, Fe has a 3 plus, O has your 2 minus.
I thought we could pick any one for iron.
In a singular place, we could. We couldn't do that here because it was iron 3 in the reactants, okay? So I had to say iron 3. You have two things of homework. Double replacement. The first page tells you what is on it. I'll wipe your desk down today. But